Hi, welcome to the next Arduino circuit board training session. In this training lesson, we will be going over series circuits and parallel circuits, and also Ohm's law. A series circuit is a circuit where both buttons needs to be pressed to work. So if you remember from last lesson, we just had a very simple circuit where if you just press the button, the LED light would just light up. But here what we have is actually two buttons so that both buttons needs to be pressed so that the LED will light up. As you can see, the 5-volt has a wire that's connected to a 220 ohm resistor, and then that resistor is then connected to a push button, which is followed by another push button. So if we push this button, the wires will actually be connected, the electricity flows, but the electricity is once stopped here again where there's another push button. So if you press if you press both buttons, the electricity will actually flow through the entire circuit, so the LED will light up. Let's see how we can make this in Tinkercad. So I have my Tinkercad open here. We can go into Arduino and then select the breadboard one as usual. I'm going to zoom out a bit. And then we can remove these two wires because they're not necessary for today's project. Let's search up resistor first so that we can actually get a resistor in and working. So I'm going to put the resistor in the plus sign once again, because remember, the electricity will start flowing from the plus sign. And I'm going to change the resistance amount to 220 ohms. What I'm going to do after that is I'm going to have two buttons, so two push buttons. I'm going to have one button there, and the second button is going to be right next to the other button. And then I'm also going to have the LED light, which will actually light up right over here. What I'm going to do now is I'm going to connect these two buttons together, and also the button to the LED, and then the LED back into the negative sign. Let's see how this circuit is actually working. So if I zoom in a bit, you can see that the plus sign wire is connected to the resistor via the metal strip, as we talked about in the last video. And then the resistor is actually connected to the button directly under the metal wires. So the button actually has to be connected to terminal 2A. And then the terminal 1A, we have an out, so that if we press the button, the electricity is actually going to flow to the second button of terminal 2A. So if I press this button, the electricity will be released into the second button. But then the electricity hasn't been released yet in the second button. So if you press both buttons at once, the electricity will be released and then the LED will light up. So if I start the simulation, if I just press one button, the LED isn't lighting up. That's because the electricity is only reached up till here. So the electricity is actually paused at the second button. But for me to make the electricity actually flow, you need to press both buttons, which is limited by Tinkercad's abilities. So if you have an Arduino kit in person, you can try this out. But for now, just know that this is a circuit series circuit where both buttons needs to be pressed in order for the LED to light up. Now let's talk about what a parallel circuit is. A parallel circuit is when both the buttons, so two buttons, we have two buttons once again, but only one of them needs to be pressed in order for the LED to light up. So as you can see very similarly, the 5-volt is connected to the 220 ohm resistor, which is then connected to two buttons. But notice here, the electricity is actually flowing in two different directions. So if I press only one of these buttons, it'll then flow to the LED and then back into our circuit. So let's see how we can make this in Tinkercad. Let's go back into Tinkercad. I'm still going to keep our two buttons, but the wiring is going to change a bit. So I'm going to connect this wire all the way to here. Let me explain why I did that later on. And then I'm going to connect this wire all the way to the LED. And then I'm going to connect this wire all the way to the LED again. And then this wire back into the negative sign. So if I start the simulation, notice how if I only press one of them, it'll still light up. Let me explain the circuit to you. So I have my resistor here, which is actually providing electrical signal to this button right at the top. So if I press this button, what's going to happen is that electricity will get released in terminal 1A. So terminal 2A actually takes in the electricity from the resistor, but when I press it, electricity will be released in terminal 1A. So when the electricity is released, what happens is that this wire actually will take the electricity and go all the way over to the LED and power this LED, because remember, all the wires are connected by metal wires. So it'll power the LED, and then the LED will go back to negative and then flow all the way back into our Arduino. Now let's see how the second button is powered. So we have our resistor once again, but notice here we have a different cable. This cable or wire is connected directly to the resistor. So the electricity, it goes into the resistor, up the cable, and then into terminal 2A once again. So if the electricity goes into terminal 2A, what we have to do is when we press this button, electricity will be released from terminal 1A. So when electricity gets released, it'll travel through this cable all the way up into our LED once again. And then when our LED gets powered, it'll send the signal back into the negative sign, and then it'll go back into the GND. So if we do another simulation, you can see if I press this button, this wire is getting powered, the one at the very bottom. But if I press this button, the electricity first travels through the top wire. The button allows the electricity to be released, and then the electricity is then goes to the LED through this wire. So that's a parallel circuit. Now let's take a look at what Ohm's law is. So Ohm's law. Ohm's law just basically states that the voltage is the current multiplied by the resistance, or simply we can say that V equals IR. You can remember it this way as well with the circle diagram. Let's say that we want to find what the voltage is. All I'm going to do is I'm going to cover the V. As you can see here, it's darkly shaded. And then the only two elements that are left is I and R. So we know that voltage is I times R. But let's say that I want to find the current. So all I'm going to do is I'm going to cover the I, and you can see that V and R are the only ones that are left. But V is the one on the top. So what I'm going to do is I'm going to divide V by R. So I get that the current is voltage divided by resistance. And similarly for the resistance will be just voltage divided by the current. Let's take a look at this example. Remember in our very simple circuit, we had that, let me make the circuit again for you. So I'm just gonna stop the simulation, delete all the buttons. Let's take a look at a very simple circuit. So I'm going to have an LED here. And then what I'm going to do is I'm just going to connect the LED back into the negative sign. So if I start the simulation, the LED actually just lights up like that, right? What's happening in this circuit is, but at this point you should be able to understand how the circuit works. So electricity goes up the plus sign, gets delivered directly this time to the LED rather than having to go through a button, and then the LED gets back into the negative sign and then goes back into our Arduino kit. But notice here the resistor is already at 220 ohms. So we know that resistance is 220 ohms. But notice here this was actually the 5 volt one. So 5V will be our voltage or the power, right? So what we can say is that 5 is equal to 220 times the current. And remember what the current was. The current was how much electricity is flowing through. So if we look back at our formula, voltage, V, was 5. The resistance was 220. So we can say that the current is 5 divided by 220 by simple algebra. And we get that this is 0.023. And we can convert this into 23 milliamps. So this would be 0.023 amps. But then we can convert this into milliamps to get 23 milliamps. That was it for today's lesson. Now you know the basics of circuits and how a circuit works. In next lesson, we'll be covering very simple projects that students will be completing.